So this video is Integrated 3, Semester 2, RFF number 4. And on this first problem here, we are doing a difference of two cubes, and the formula is a cubed minus b cubed is equal to a minus b times the quantity a squared plus, that's always opposite of that sign in the first parenthesis, times ab plus b squared. So the cube root of 125x cubed is going to be 5x minus, and the cube root of 64y cubed is 4y. Then I'm going to square my 5x, which is a 25x squared, change the sign, so it's a plus, multiply my 5x and my 4y together, 20xy, and square my negative 4y, which is a 16y squared. And that's your answer. On number 2, we are going to solve this quadratic. So first thing I'm going to do is I'm going to have my x squared minus 9x minus 4 equals 0. You want everything on one side, 0 on the other. Let's see if this is factorable. I believe it is factorable. So we can do a box to diamond, or we can just do the factors, but let me just do a box to diamond. So this would be a 5x squared. This would be a negative 4. That multiplies to a negative 20x squared, but it has to add to that negative 9x. And then what multiplies to a negative 20x squared and adds to a negative 9x? That's going to be a negative 5x. Let's see, that's supposed to be negative. So wait, hold on. That's going to be, well, negative 5 and a negative 4, but that gives me a positive 20, 2 and 10. So I think this is actually not factorable. So we're going to have to use quadratic formula or complete the square, but completing the square with a number from the x squared isn't as nice. So quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to have 9 plus or minus the square root of negative 9 squared minus 4 times my a, which is 5, my c, which is a negative 4, all over 2 times my a, which is 5. Okay, so I get 9 plus or minus the square root. And let's see, we put 81 minus 4 times 5 times negative 4. And I end up getting a 161 over 10. And 161 over 10 cannot be simplified. So that's our answer. On number 3, we're going to write a polynomial equation that has the following roots. Okay, so the 3 is going to give me, is going to come from an x minus 3. The negative 1 is going to come from an x plus 1. Now, this is the part that's going to be tricky here. When you have this root 3, any square root or imaginary number, you also are going to have its conjugate. So you're also going to have a negative 3. You're going to have a positive and a negative of that square root or that imaginary number. So the root 3 is going to come from x minus root 3. The negative 3 is going to come from x plus root 3. And then we're going to multiply these together. So if I multiply these, I am going to get x squared minus 2x minus 3. And when I multiply these, that's a difference of 2 squares. I'm going to get x squared minus 3. And now I can do a box, or I can just distribute all of that, but I think it might be easier like this. Okay, and this. So this is going to be x to the 4th minus 2x to the 3rd minus 3x squared minus 3x squared, 6x, 9. So I'm going to get x to the fourth minus 5x. Sorry. Minus 2x cubed minus 6x squared plus 6x plus 9. And that's our answer. On number 4, we're solving this. I'm going to fraction bust this. I'm going to multiply everything by 12. So I'm going to take 12 times x minus 1 over 4 minus 12 times x over 3 equals negative 2 times 12. And when I do this, 4 goes into 12 3 times. So I get a 3x minus 3 when I distribute. Over here, 3 goes into 12 4 times. So I'm going to get a negative 4x. And on the other side, I'm going to get a negative 24. So I get negative x minus 3 equals a negative 24. I get negative x is equal to negative 21. So x is equal to 21. On number 5, what is the sum of the roots? Okay, so for this, I'm going to look at my factors of my back, which is p, and my factors of my front, which is q, and it's p over q. But q is 1, so I basically want factors of 24. So I'm going to have 1, 1, negative 14, negative 24. And let's say I start with 1. I get 1. 1 times 1 is 1. I added, I get 2. 2 times 1 is 2. I added, I get negative 12. Negative 12 times 1 is negative 12. I added, I get negative 36. Okay. So let's say I try 2. Again, I want things that are factors of 24. 1 times 2 is 2. I added, I get 3. 3 times 2 is 6. I add it, I get a negative 8. Negative 8 times 2 is negative 16. I get a negative 40. Let's see, 3. Let me try a 4. Let me see how 4 goes. 4 times 1 is 4. I add it, I get 5. 5 times 4 is 20. I added, I get 6. 6 times 4 is 24. I got 0. If I had gotten a positive number instead of just 0, I would have known that maybe 3 was a possibility because I am below the x-axis, below the x-axis. Here I'm on the x-axis, but if it had been positive, I would have been above. So at some point in between my below and above, I have to cross. Okay, so I know x equal 4 is an answer. And then I'm going to take what's left here, which is x squared plus 5x plus 6. Set that equal to 0 and solve. So it's going to be an x plus 3, x plus 2. So I get x is equal to negative 3, x is equal to negative 2. So they want the sum of it. Okay, they asked for the sum. So 4, basically minus 3, minus 2. I end up with a negative 2 as the sum. Okay, so the answers that I got a 4, I got a negative 3, and I got a negative 2, but they wanted the sum of them. So I'm going to add them up. Okay. On number 6, so this is going to be y equal a times, and the negative 3 comma 0 came from x plus 3. The 2 came from x minus 2. The 6 came from x minus 6. And then I'm going to put this point 4 comma negative 12 in for x and y to find my a. So this is going to be 4 plus 3, 4 minus 2, 4 minus 6. So negative 12 is equal to a times 7 times 2 times negative 2. So I get negative 12 is equal to negative 28a. So I'm basically going to get divide by negative 28. So I get a is equal to positive, and 4 goes into the top 3 times and then to the bottom 7 times. So y is equal to 3/7 x plus 3, x minus 2, x minus 6. And that's my answer. On number 7, find the degree and describe the end behavior of the graph. So this, I have a 3 plus a 6 plus a 2. So that's 8 and 3. So I get an 11. So it's degree 11, which is odd. And so what that means is, since it's an odd positive, it's like an increasing line. Increasing lines start below and end above. So my end behavior is going to be down, up. I'm starting below and ending above. On number 8, okay, we're going to write the equation of this polynomial. Okay, so it looks like I have a 0 here at -1. I have at 0, that's a 0. And I have at 2. I have a double root at -1. So it's going to be y is equal to a times x plus 1 squared because of the double root, times x, that's my single root. And then I have an x minus 2 cubed. So let me just kind of clean this up. So x plus 1 squared, x minus 2 cubed. They did not give us a point to be specific about. So let me get rid of my a. They didn't ask us to find the exact one. So there we go. If they gave me a point, I would have put it in for the x and y and found my a. Okay, write the equation of the sine function with amplitude 5, period 4 pi, phase shift pi halves, vertical shift 2, then sketch it. Okay, so this is going to be y is equal to 5. And then since my period is 4 pi, period is 2 pi divided by b, and that equals 4 pi. So that means I'm going to get 2 pi is equal to 4 pi b, which means I get 2 pi over 4 pi, or 1/2 is equal to b. So I'm going to have sine 1/2. Phase shift is pi halves, so it's going to be x minus pi halves, and vertical shift is 2 plus 2. So then if I'm graphing this, here, let me drop it a little bit. Okay, so I'm starting at 2. I'm going 5 above, which is 7. I'm going 5 below, so I'm going to be at -3. This is going to be my zeros, my vertical shift. These are going to be my high, my low. And we're starting at pi halves. And I've got 1, 2, 3, 4, 5. And I got to figure out where I'm ending. So I'm starting at pi halves. My period is 4 pi. So that's really pi halves plus 8 pi halves. So we're going to end at 9 pi halves. So this is 9 pi halves. And it's a positive sign. So I am going to start here at 0, end at 0, halfway in between 0. Halfway in between that, I'm going up. And halfway between my other two zeros, I'm going down. And here, let me get a little thinner line. And that is my graph. Let me get it through the points this time. Okay, on number 10, write the summation notation for the series. So looking at this, I'm thinking that it is geometric. So I'm thinking I'm taking 216 times something to get 54, which means my R is going to be 54 over 216. Let me see if that's can be cleaned up. 54 divided by 216 is 0.25. times it by 0.25. So if I want to write this in summation notation, a couple things, I need to figure out what this is. So I know I'm going to have a sub n is equal to 216 times 0.25 to the power n minus 1. And I want to figure out 0.84375, what term that is. So I'm going to plug it in for y, or a sub n. I'm going to divide by 216. 0.84375 divided by 216 is equal to 0.25 to the n minus 1. Let me just say 0.84375 divided by 216. It isn't nice, but I'm going to hit math and fraction. So when I hit changes to a fraction, it's 1 over 256 is equal to 0.25 to the n minus 1. Then I am going to use logarithms. I'm going to rewrite it in logarithmic form. So I'm going to go log base 0.25 of 1 over 256 is equal to n minus 1. I will put that in my calculator. So I'm going to get, let's see. I end up getting 4 is equal to n minus 1, so n is 5. So I need to write it in summation notation. So in summation notation, let me write it down here. It's going to be n equal 1 to 5 of 216 times 0.25 to the n minus 1. And that is our equation. On number 11, what is the phase shift in the period? So this pi halves is our b, and period is equal to 2 pi over b. And so that's going to be 2 pi over 2. Two pi times the reciprocal of 2 over pi. So my pi's are going to cancel and I end up getting a 4. That's my period, 4. Phase shift, I'm going to take pi halves x minus pi 6, set it equal to 0. So that's going to be pi halves x equals pi 6. I'm going to divide by pi halves, or times it by 2 over pi, which is the reciprocal. And so when I do that, pi and pi cancel. And over here, the 2 pi's, that cancels. So I get x is equal to 2 over 6, or 1/3. So that is my phase shift. And this is the period. So on number 12, this is an interest, compound interest, 0.25% compounded quarterly. So I'm going to take 2.5% and write it as a decimal. I'm going to divide it into 4 equal increments. So I'm going to take 0.025 divided by 4, and I get 0.00625. And when I do this as a multiplier, I am going to have as my multiplier, because it is, if I move my decimal 2 places, 0.625% every quarter. So it's going to be 1.00625 is my multiplier. Got to add it onto the 1. So let's see. We're starting off with 550 times 1.00625 to the power x. And it's not an x. It is 4 times a year for X years. Is equal to 1200. So 1.00625 for X is equal to, I'm going to divide by 550. And I end up getting, as a fraction, I end up getting 2/4/1/1. And I put it in my calculator as a fraction. So 24/11. I'm going to rewrite it in logarithmic form. So I'm going to go log base 1.00625 of 24/11 equals 4x. So let me put that in my calculator. And I get 125.215, let's say, is equal to 4x. I'm going to divide by 4. And I get 31.3 years as my answer. On number 13, properties of logarithms. So real quick, this right here, I am going to rewrite. That is going to be z to the 4/3. Z to the 4/3. So I am going to have, I'll do it in 2 steps. Log base 5 of q to the 8th minus log base 5 of p minus log base 5 of z to the 4/3. Then all the exponents get moved in front. That's one of the properties of logarithms. So we have 8 log base 5 of q minus log base 5 of p minus 4/3 log base 5 of z. And that's your answer. So anything that's multiplying on top will be added. Anything that's on bottom is going to be minused. And your power gets moved in front. So now we're going the opposite direction. So again, let me just do it kind of step by step. So this is going to be log base 2 of a to the 3/5, and I'm going to change that around here in a second, minus log base 2 of b to the 2/3 minus log base 2 of c to the 5th. So a to the 3/5, I can really rewrite that log base a of the 5th root of a cubed minus, let me just make that 5 look better, minus the cube root of, sorry, let me get my log in here. So minus log base 2, it's bigger, of the cube root of b squared minus log base 2 of c to the 5th. Now I can write this as a single logarithm. It's going to be log base 2 of something. Well, on top, I'm going to have the 5th root of a cubed. On bottom, because of the minus in each of them, I'm going to have the cube root of b squared and c to the 5th. And that's your answer. On 15, looking at this, I'm thinking this is maybe arithmetic. So let's see, 2, 4, 5 plus something gets me 233. So I'm going to subtract and get a -8. So it looks like I'm subtracting 8 here. So they want to know the sum. So for the sum, I do need to figure out what term that 77 is. So let me write first a sub n would have been equal to 2, 4, 5 minus 8 times n minus 1 is kind of your general equation. I want to know what term 77 is. So I'm going to put that in for my a sub n and work this out. So I'm going to minus 245 from both sides. And I get a negative 168 is equal to negative 8n minus 1. I'm going to divide by a negative 8. So I get 21 is equal to n minus 1. So 22 is my n. So this 77 is my 22nd term. And I want the sum of the first 22 terms. So, and this is arithmetic, so I'm going to use the formula S sub 22 is equal to 22 over 2 times my first term, which is 245, plus my last term, which is 77. Let me put that in my calculator. And I get 3,542 as my sum. And that's the end of this video.